Okay, so we're going to look at today finding the general rule of a linear pattern. We've met this term before, linear pattern, but we will just revise it. In front of me here I have a sequence of numbers, 6, 10, 14 and 18. I refer to 6 as term 1. And if I have a look at it, I can see that there is the same difference within each of the terms or within each of the number sequence, and it is a plus 4. Plus 4 and plus 4. So a linear pattern is a sequence of numbers whose common difference, so CD, is the same or constant. In a linear pattern or sequence, the difference or the change between one term and the next is always the same number, and we refer to that as a constant, the same value. So 6, 10, 14, 18. If I was to recall 6, its term, it would be term 1. 10, term 2. 14 is term 3, and 18 would be term 4. Now if I asked you to find for me term 5, because we know the common difference of the CD is plus 4, it'd be quite easy to spot that term 5 is 22 and term 6 would be, say, 26. But the problem would be if I asked you, okay, can you tell me term 58? Okay, so yes, we could keep adding on 4 until we get to term 58, but in maths, we would like to be able to come up with a rule that would help me figure out exactly how to find term 58 and term 558 if I wanted. Okay, so what we're looking at today is we are looking at finding the general term, and the general term is another word for finding the rule of this number sequence. Okay, so now that we know what we're looking to do, let's learn the method. If I'm looking to find the rule, I am looking to find term n, where n can be any number I want it to be. So when you're given a sequence, you can immediately find term 1. So say if I'm given the sequence 2, 6, 10, 14, I can immediately find term 1, find term 2. It's possible I've already been told term 3. In this case, I already know term 4. But if I can find term n, it means I can find whatever term I want. So that's what we're looking for. We're looking for t to the n, which is the general term of a sequence, and it can be used to find the value of any term. Okay, so we're faced with our first example here, and the question says, find the general term, or we could say the rule, for the following linear sequence, and hence, which means once you've done that, find the 50th term. Okay, so let's just first of all make sure it is a linear sequence. I've got the numbers 2, 7, 12, 17, and my start term is number 2. That's important, I'm going to need that. And I'm also going to need my common difference. So my common difference in this case is plus 5. 7 to 12 is again plus 5. And 12 to 17 is plus 5. So I can conclude that yes, this is a linear sequence. It's got the same common difference. And my common difference is plus 5. So step 1 in finding the rule for any general sequence or any linear sequence, you must find number 1, the start term, and number 2, the common difference. So that is step 1 always. My next step is to lay out a table that will help me figure out the rule of this sequence. Okay, and this is how all of our tables must be laid out. They must consist of 4 columns. The first one is term number. The second one is CD, which stands for common difference multiplied by term number. And the last one is term value. I'm going to show you what you do with this middle column later on. So I'm going to fill in, first of all, the term numbers. And so the term number I'm going to fill in, first of all, will be term 1, term 2, and term 3. The term I'm looking for at the end is term n. But what I'm hoping is if I can figure out the rule that happens with term 1, 2, and 3, I can then just apply that rule to term n. The term value is the next column that we fill in. And so here we just say what exactly is term 1. And in this instance, term 1 is number 2. Term 2 is number 7. And term 3 is number 12. Okay. Within this column here, I'm going to leave this bit blank because I don't know what term n is yet. Term 1, we now move into the second column, which is CD multiplied by term number. And the CD stands for common difference. And the common difference we figured out in this sequence here is plus 5. So it's the common difference multiplied by the term number, which in this case is 1. So it will be 5 multiplied by 1. And my answer here is 5. Here I will have 5 multiplied by the term number, which in this case is 2. And the answer will be 10. And here I will have 5 multiplied by term 3, which is the term number 3, which is 15. Okay, I now apply this method to the last section here, which is t to the n. So it is the common difference, which is 5, multiplied by the term number, which in this case is n. And 5 multiplied by n is the same as 5n. Okay, so that bit there is really important. Okay, I now go up to this section here, this column, and I'm going to try and figure out, well, what did I do to this 5 to get a 2? And the answer is, I subtracted 3. What did I do to this 10 to get a 7? And the answer is, again, I subtracted 3. And the 15 to get a 12, I subtracted 3. So if it was 5n, what would I be doing here? I would be subtracting 3. And this here, guys, is super important because this is the rule for whatever term you want to find. It is 5n minus 3. So, I've found the general term or the rule for this sequence. Whatever number I'm looking for, whatever term I'm looking for, I just use this formula, 5n minus 3. So I'm going to make this a little bit smaller, give myself a little bit more room. The question up at the top here said, find the general term. To find the general term, step 1, I find the start term and the common difference. And step 2 is I lay my table out and fill it in correctly. What you should be left with at this point is your general rule, which is this bit here, 5n minus 3. That's going to help me find whatever term I wanted. So term 1, term 2, term 3, term 4, I can find them all using this general rule. And in this case, the question asked me to find the 50th term. So what I am looking for here, first years, is term 50. Okay, so I'm going to make this a little bit smaller, so I have a little bit more room to play around with. Okay, so as I said, I'm looking for term 50. I know that term n, the nth term from my table is 5n minus 3. That is my general rule. If I am looking for term 50, I am now going to write, well, term 50 must be equal to 5 times 50 minus 3. Remember, n stood for whatever term I was looking for. So the question here is asking me to find term 50. So now instead of writing n, I'll write 50. But you can see here that there's no plus, there's no minus in between these, which means that this is attached or together, and it means it's 5 times 50 minus 3. And 5 times 50 is going to give me 225 minus 3. So the number that is term 50 in this sequence that started off as 2, 7, 12, the 50th term here is 225. So there's a lot to take in there. Best thing you can do, first years, is to follow the simple steps. So step 1 here is you are finding your start term and your common difference. Really important. Step 2, you draw your table and complete. You must learn these headings off by heart and be able to draw them. That will help you figure out this bottom one here, which is t to the n, which is our general rule. Once we've figured out the general rule, I can find term 50 by substituting in. I can find term 550 because the rule does not change for this number sequence. Okay, so we're now looking at example 2, and it is find the general term or the rule for the following linear sequence and hence find the 65th term. So I know that 6 is term 1, 8 is term 2, 10 is term 3, 12 is term 4, and I'm actually asked, well, what is term 65 going to be? And I'm going to use a formula known as the general formula to help me figure this out. In order to find the general formula, we need to follow 2 clear steps. Step 1, find the start term, term 1, and the common difference. So term 1 in this case is 6, and the common difference in this case is plus 2, and between 8 and 10 is plus 2, and between 10 and 12 is plus 2. So the CD is equal to plus 2. The next step I follow is to draw and complete the table. As spoken about earlier, I need to know these titles of the table completely off by heart. Okay, so I've just placed the table down here, and it is term number, CD multiplied by term number, and term value. So term number, we're going to do the first 3, and hopefully that will help me figure out what I'm looking for, which is term n. So we've got term 1, term 2, and term 3. The common difference is 2, so here it'll be 2 multiplied by term number, which in this case is 1. That gives me 2. The term number here is 2, so it's 2 multiplied by 2, which gives me 4. And the term number here is 2 multiplied by 3, which gives me 6. And down here I would have the common difference multiplied by the term number, which in this case is n, we don't know. So 2 multiplied by n gives me 2n. Along here I fill in the term values, and so this is what the values were. So term 1 was 6. Term 2 was 8, and term 3 was 10. And I ask myself, okay, I'm at a 2, what do I need to do to get to a 6 here? And the answer is I need to plus 4. I'm at a 4 and I need to do something to get to an 8, and it is plus 4. I'm at 6 and I need to do something to get to a 10, and it's plus 4. And what you can see here, first years, is that I am doing the same thing to every single number, which means that if it was 2n, I would be adding 4 also. And that is the hardest bit done, because this now is our general rule. Once we find our general rule, we can now find any term we're looking for, and in this instance we're looking for 65, the 65th term. So I'm going to just make this a little bit smaller, move it up a little bit. And so we found term n is equal to 2n plus 4. That's our general term. And I've been asked now to find the 65th term, which means I'm looking for term 65. And so wherever I've got an n, I'm now going to place 65, and it will be multiplied by. So 2 times 65 plus 4 is going to give me the answer to that. I'm going to give myself a little bit more room here, make it a little bit smaller, move it up. Okay, so 2 times 65. Remember BIMDAS, remember brackets means multiply. So 2 times 65 is going to give me 130, and then we have the plus 4, so the 65th term here is 134. So if I went on and on and on, term 65 would be 134.